Well, this is Val Campbell, and I'm in studio with Chris Augustine today, and I've been just waiting to get him here so that we could talk about a subject that I know is really near and dear to his heart, because when you and I met 6 years ago, like almost right away, you were animated about the subject of cross-laminated timber, sometimes called mass timber, right?
Yes.
And Chris, why don't you just go ahead and take this and kind of run with it a little bit and tell us what is that? Because before that, honestly, I've been in the construction industry a long time. Wasn't aware of this, but now I am. It's just a big deal. So why don't you go ahead and take this and tell us what this and what's exciting to you about it and where's it going?
Well, yeah. Hey, good afternoon, Val. And yes, CLT or cross-laminated timber, mass timber, if you will, caught my attention many years ago. And what it is actually is it's an engineered structural or, even non-structural building element that is made out of wood. And there are obviously other ingredients like glues and pressure and those create these wood shapes, whether they be beams or columns or panels or any number of products. And they caught my attention because, well, for a number of reasons, but I have been thinking about the aging workforce and the amount of labor that's required on these traditionally stick frame projects or these traditionally concrete and steel projects, and the amount of intensive, not only environmental but economic footprint that they have, whether they be mostly manufactured overseas or manufactured onshore and then traveled. But so you get at first you get this kind of double benefit where you not only get to replace those carbon intensive materials, but you also are using sequestered carbon to do so. And
what does that mean? You said sequestered carbon. What does that mean?
Well, that means that the wood, basically the trees pull the carbon out of the atmosphere and use it as part of their growth process and photosynthesis. And that carbon end up getting stored in the tree. And so as you process that tree into CLT or lumber, that carbon is captured. And that's as would compare to a piece of steel or a yard of concrete, where you have a whole industrial manufacturing process associated with fabrication that basically is carbon intensive. And just it's quite striking how you can move from a very intensive process to a process that is actually pulled that carbon out of the atmosphere and ties it up, if you will, inside the building in those wood elements. Not so unimportant as well is this just the beauty of wood. And you have, the ability with some of the progress that's been made from an engineering standpoint to be able to feature that wood. And it creates what an architect might call a more warm and stable and environment when compared to some of the other building materials that get left exposed or covered up with drywall or any number of finishes. So there was this a little bit I was able to read about it. It started to get excited about it because it's much more widely adopted in Europe. They were way ahead of us in terms of the building heights that can be constructed out of wood. Until very recently, I'm jumping around here a little bit, like only in a matter of a couple of years, the IBC in the United States would not allow wood structures, stick framed really, over 5 stories. That's why when you drive around your city, you see all these concrete podium and 5-story high stick frame apartments, because that ends up being the most economical way to deliver those housing units. But over 5 stories, we didn't contemplate it. And yet there are many, many, many higher buildings that have already been constructed in Europe using the same products. And so the engineering and the code had to catch up. And that also, the other feature benefit, I'll step, the labor force it takes because this is so highly engineered up front, it's essentially a prefab. And so you're bringing out these pre-manufactured panels and systems that are all planned out way ahead of time, so that all your MEP penetrations and all your rough ends are all planned for ahead of time. So you really build the building in the BIM or in the computer model before you ever cut a piece of wood. And there have been great advances in fasteners and connectors, and you've got these much more elegant systems now that are more concealed and stronger. So anyway, backing up to the point of the conversation, I got interested in it enough to just go to Portland. They had the second or third annual Mass Timber Convention down there. And I remember very clearly, I can't recall a year, but I was the only builder in the room. Well, that's not true. Maybe a couple other builders, but it was mostly architects and engineers. And there was probably 40 or 50 people at this thing. And a bunch of the speakers were from overseas, and it felt super early. The last one that I went to a couple of years ago, hundreds and hundreds of vendors and contractors and engineers, and it's got a wide, a much higher level of understanding now. And there are domestic manufacturers in lieu of just the overseas folks that had to ship their CLT here. And this whole vertical of forestry and logging and CLT manufacturing is, potentially where things are headed. The idea of being able to, help solve the labor crisis where we can't find enough skilled labor because you end up using a much less number of people because you're essentially picking with a crane and setting with a crane and connecting, versus a lot of the other technologies like concrete requires you to form, reinforce, and pour, or even steel requires you to bolt, fit, and most cases fireproof, monocoat. You've got these added processes that add labor and add time.
Not to mention the interior finishes and framing and drywall and suspended acoustical ceilings sometimes and things like that add a tremendous amount of complexity to the project.
Yeah, and I'm not a code expert, but I know that there are some still progress to be made with regard to what you can leave exposed and what you have to cover with like a type 2 or some sort of fire rated assembly. The exciting thing is that the way CLT has been tested, that they actually have proven that if it's in a fire, it develops a char, much like you would see in a forest fire where the whole tree's not gone, but it's just literally the bark char. The char protects it from burning completely. And so I know we've got some progress to be made there, and I have my sense is that over time you're going to have more and more wood that's subject to exposure, and you're going to just see the benefits increasing in terms of the kinds of things that you're talking about with labor and materials and finishes and things.
Well, and certainly you have shaft systems and egress and other things between floors. Those would understandably probably need to be more protected. We could understand that. And you probably have some mechanical shafts and things like that need to be constructed a little bit differently. But I know when I started looking at this with you, it was amazing how beautiful the insides of these buildings were. It wasn't just this cream color painted monolithic surface type thing. It was the texture and the grain of the wood that was being brought out. So it was amazing.
Yeah, and there you need to be a little more creative. And still the industry views this as a premium. And I think that as a recovering developer, I think that one of the big items or elements of this integral with CLT that gets a little overlooked is time and CapEx. And so in a traditional project, you have the foundation. Your foundation system can be lighter, pretty much, because not in all cases, but in most comparative cases, because you have less mass and you have the ability to save money there. And then you have the ability to put the finished building together much, much quicker. Some would even say 30% or so. And if if I could show you a way to save 30% of time on a large project and save the carry costs, bring it to market faster, and start generating revenue, that's a benefit in my mind. And so you've got to really do an overall economic analysis. And I still feel like there is room to improve with regard to our understanding of just how tall and just how best practices from a design standpoint utilizing CLT. There is a market that still needs to develop. It still needs broader adoption, in my opinion. But I think the economic analysis has to be, the performa analysis has to be done correctly, considering all the factors of that choice. And that's what we used to do when we would sit down and figure out whether we wanted to do a building out of LGSF or out of stick, or out of, we would look at how many units we could put on that site from a land use standpoint, and then we'd start looking at different building materials and different systems to decide from an economic and a goal for the project aesthetically and functionally standpoint, which systems made the most sense. And I think if you include CLT in that conversation, not for every building, but certainly for some, and more down, as we go, it'll be the choice.
So take us right from the start, if you would, and how does this happen? Because I think that's a fascinating process and it's very different from conventional construction, right?
It is to me, and there are some common elements, right, to all building design and construction, and at least in our world, in our space. So really starting from the beginning, it's a cost model analysis, right, and it's a kind of a massing, if you will, understanding, and you get a little further design down the road on the architectural side. But at some point you have to pick your system, and then the structural engineers, I was always fascinated by the idea that the architect designs the building from the bottom up and the structural engineer designs the building from the top down, because they're competing interests in some ways in terms of how do you fold that structure in discreetly, and the good ones can do it very, very well, and it's evident when it happens, right? That being said, once you pick your system, then you're basically engaging with industry pretty early, because there's a lot of expertise in industry with regard to the special considerations for CLT. And you have, you're doing this stuff in these factories where they're working off of a design that basically is a kit of parts, if you will, to keep it really simple. So every single panel, every single beam, every single column, bolt, connection hardware, it's all basically scripted. And then it works as an explosion of an assembly and then a consolidation in the field. And so the factory and the contractor and the developer and the architect and the engineer all have to work together early on to essentially incorporate the mechanical, electrical, and plumbing system, to incorporate the curtain wall or the window wall system, to incorporate these choices that are made to be integral with CLT, which is the guts and the bones of the building that hopefully can be exposed to view in an interesting way and create a really special space.
So the design and engineering team, work in a computer-aided design environment, a CAD environment, and they create this building design in intricate detail, because this is going to be manufactured someplace and brought out into the field essentially and just bolted together. So all of that pre-thinking, that's what you're describing, that has to happen. And then how is this material manufactured? Because let me lead you a little bit here. This is like plywood on steroids, if you will, right?
Yeah, I mean, you've got different species of wood that have different characteristics. You've got softwoods and harder woods. You've got different manufacturers that will specialize. There's also the limitation of travel. So you could probably make a CLT panel that was a lot wider than you could travel it, and you'd stand it up. So there's all of those considerations that have to go into what is the manufacturer's limitations on panel sizes, what are the truck haul limitations on panel sizes, and then you've got this incredible effort of logistics in terms of how the order of arrival to the site and the timing of that. Because essentially, imagine if you're bringing everything out that's a completed assembly and it's simply being bolted together in accordance with the design, you've got a lot of consideration for the order of arrival and storage. And if you have a little hiccup, what happens is that trains start to slow down. It's a very, plan and execute. And that is a difficult element, because with the traditional building elements like concrete and steel, you can modify some things, or some things weren't fabricated correctly. If a CLT panel is misfabricated, it's a little more difficult to hide it, if you will, within, because if it's exposed, or if the plumbing chases got drilled in the wrong spots, you don't want to see a bunch of plugs, but that's, some of that stuff is less easy, I guess, if you will, and more fragile.
Right. So they've got these monster machines that make these, CAD CAM, computer aided manufacturing, then, that create this material to the specification from the CAD drawings.
Within the family of the selected mass timber provider, they're going to have, like I said, some panel families and some column families and some beam families and things like that. And then that's why I think the industry has to work with the design teams to ensure that level of quality of review and thoughtful design gets considered based on what their manufacturing process is. And you can go online and watch some cool videos of how CLT is made, and it's got this process with presses, and it's a pretty. And then you've got CNC machines that will cut these very precisely in terms of openings or penetrations or anchorage details. You've got knife plate details that can conceal, but you've got to figure out how to connect those in the field and make it constructible. I just think industries just going to get better and better at it.
Well, to a certain degree, and I'm sitting here chuckling a little bit because I'm thinking of IKEA cabinets or IKEA furniture, right? Shipped all over the world in a micro. I mean, that's kind of the same thing, right? You bring it out. This stuff is very precisely engineered. It is manufactured. You just take it out of the box and you bolt it together and put it in your kid's bedroom or something.
Well, and not to get too far down a different rabbit hole, but steel and concrete are a little bit easier to work with the weather. Wood is naturally going to respond to the elements differently. And so seasoning and drying and protection in the field, especially here, like someplace here in the Pacific Northwest, is a factor. You've got to think about it, and that depends. Work with how is it wrapped? How does it arrive on site? How does it get unwrapped and put into place? And all of it, and safe material handling practices. You got a lot more hoisting and crane work, which requires careful coordination and paying a lot of attention.
And yet, the payback, of course, is the speed with which you can erect these buildings on site. You're in a way, you're transmuting a bunch of people working in the field, a bunch of bodies out there, for a lesser number of people doing project management and engineering, and really getting that coordination down, making sure that all of the sequences and the sequential components are manufactured and shipped and lined up and coming.
I would maybe put it this way without offending anybody, but you have more with perhaps less professional skill, and you have less with more professional skill in CLT because of its inherent nature. And that bodes well for our labor force because people can stay in longer. You know, if you put somebody in a factory working in factory controlled conditions, first of all, you have less people in that factory, but you can control safety better. You can control distance to travel better, right? Because you know now you're not getting a job in one part of the city and then the next job is in three cities away. As would happen in construction, we're fairly migratory in that regard. And this is it's a skill. It really is a skilled trade. And I just see the ability to read plans even and understand sequencing and understand the elements effect on the project and those kind of things that they just have to all be higher.
I would not think that this would be offensive, as you mentioned, because quite honestly, and as we know, those workers just don't exist anymore in the same numbers and the same quality. It's just not something that people are that interested in. So in a way, I think this follows the natural trend and desire of the workforce to work more on that technical side, more on the skills side, if you will, and not so much quote unquote blue collar.
Well, just think about safety for a second. How hard the traditional trades are on a person's body over 25 years. And yes, you're still doing lifting, you're still working. It's still very hard work, but you are using machine and planning to put yourself in a safer position, not only in the factory but out in the field.
Right. So once the building is being erected, then you have some, I don't know, I want to say more traditional elements going in, as you cut MEP, mechanical, electrical, plumbing, and those are again pre-designed to be able to fit in the mass timber building because the openings and the penetrations are already milled into the wood structure, right?
I mean, that's the goal, right? That's the ideal. And it's also an engineering effort because the spans, just like steel and concrete, you can only penetrate a diaphragm, to a certain degree before you start to compromise its integrity. So, having those things thought all the way through from the beginning is paramount. And, your air distribution system choices, your sprinkler system choices, all those choices have a bearing on, that assembly of parts.
It's such an interesting dynamic, how we're making some of these technological shifts. And I know it's a different subject, but I was just reading recently that IBM had laid off 8,000 workers, and they were touting how AI was going to be a reduction in their workforce. So what they found out was that they ended up hiring 8,000 people back, but they were doing different things. They were doing more technical things, less of one thing, more of another. I just think that's interesting. But I definitely, from my experience in construction, I could see that this would be a net reduction of bodies on a job site. And in most of the cases, from a business standpoint, that's where a lot of your risk comes in. That's where a lot of your exposure to injury comes in, right? So yeah, it's a big deal.
And I do like the idea of the forestry model, because if a managed forest is really a renewable product, and that is unlike, concrete and steel can be recycled, right? But they have also it's not as, I don't believe it's as elegant a model, if you will, as it relates to all the things that the using wood does intrinsically.
And from what I understand, the life cycle of these structures is around 60 years. Probably would be longer than that, but that's what's documented. And I don't know that there's a lot of buildings that even with steel and concrete that are projected to life use much longer than that. Maybe some, but that's still quite a while. If somebody wanted to know more about CLT or mass timber. They want more information on this and interested in learning how to take advantage of the features it offers. We're going to have your information down below here. They can contact you. You can help walk them through that.
Absolutely, and there's some really good associations that we have here in the Pacific Northwest that are, because we're a forestry legacy part of the planet, and so there are some good associations, and there's a lot of good free information out there, and I'd be more than happy to talk to somebody that would be more interested in learning more about it.
So as a bonus here, one of the better stories that you shared with me over the years is your interest in how you came about the name Coho. Can you share that with us as we're walking out the door of the studio here?
Sure. Yeah, sure. Well, we bought the company as a boutique general contracting business, and I understood deeply the importance of name and brand, and I really, because this was our first company that was just us, I wanted it to not just be a name. I wanted it to resonate and mean something. And so I had, half a dozen candidates, kind of like, that's almost like naming your kid. I was really important to me that our kids had names that meant something to us, and not just 4 or 5 letters or whatever. I'm sure most people probably feel that way. So I was still undecided. I'm sitting at this mass timber conference in Portland, and I'm listening to the chief sustainability officer for Microsoft give the keynote address. And I like to take notes when I'm listening to try and be able to kind of put it in 2 parts of my brain at least. And this gentleman was just going I kept writing down either carbon or water, and then I just started writing CO2 and H2O. And I was deeply thinking about, the future of the company, Coho Enterprises, and how we wanted to eventually get into important efforts that related to energy and related to water and related to the environment. And all of a sudden, it just jumped off the page at me that I was writing down CO2 and H2O, and I looked at the letters COHO, and it said Coho. And one of my best and strongest memories is going fishing with my dad growing up. And Coho is a salmon that's native to the Pacific Northwest. And so it just resonated deeply with me that I could look at that word and see something different than most people would, but it still would make sense to them, if that makes sense.
I appreciate you, man. And we will see you all on the next video.
All right. Thanks, Val.